Hello everyone. I welcome you to this class of econometric methods. Myself, Dr. Muhammad Imdadul Haq, an associate professor at the Department of Economics, Aligarh Muslim University. In our previous classes, we were discussing the case of cointegration. Uh, we have seen the Engel-Granger process also, and in today's class, we will be looking at the same. We'll be looking at how cointegration can be done in a software. In our discussions, when we were discussing the case of Angel Granger, we have seen that we can do it manually in a two-step process. In the first, what we were doing was we did the regression, we got the estimates of the error term, and then we checked the stationarity of the error term. So checking this stationarity, it led to the conclusion that if the error term, the estimated errors were stationary, then we said that there existed a cointegrating relationship or a long-run relationship between the variables. And if they were not, those error terms were not stationary, we were of the impression that there is no long-run relationship between the variables. And nowadays, there are many softwares through which these advanced techniques can be done. Before moving to a software, see, there are basically two types of softwares. One of them are, you can say, the paid softwares, or for which you need a license, like eViews, SPSS, Strata. They are the paid softwares wherein you have to pay the subscription amount. The other type of softwares are free. Examples, a glowing example of it is R, and through this also you can compute many things related to statistics and econometrics. The good thing about these free softwares is that you can access them freely, you don't have to pay anything for it, but they are programming based. But traditionally, econometrics and one of the most common software used for econometric methodology is eViews. This software is basically used for econometrics. It's basically an econometric software. And one thing is, you can access this software free also. It's a licensed version. You can access this software free. Nevertheless, you need to get permission for it. But what you get it, the lacuna of this is, the free version of it, you can get it for only a year. Meaning thereby, if you just need you need to just go to just search on eViews on Google, pages will come up. Pages, I mean to say, like this, and there you can download these student version free. You can download this student version free, and along with it, you have to fill this proforma, wherein it is asking you for your name, the main thing is it is asking for your email. It will be asking you for your email, and in this email you will be getting the activation code for it. It's free. There are no ifs and buts in it, but the only condition is this license would be active for a year. Apart from this, there is a certain difference, also a small amount of difference between this and the real version, that is the subscription version. Few options are not here, but for our purpose, for the course of basic econometrics, what the options which we get over here in the even in the free version or in the student version, it's more than enough. That is much more. That is what we don't need more than that at this moment. Maybe for advanced computing or going for some advanced techniques, you need it. But apart from this, and also after the 10th version and on, lot many changes. Now we are in 12th version or 13th version is available nowadays, and you can after 10th version there has been a marked improvement. Many things are there. Also, when something new, a new technique is developed or not, that can be downloaded as such and incorporated in your existing software. We will be using this traditional econometric software to give you a demonstration of how this Johansson cointegration can be done using eViews. We could have done the Engel-Granger test manually also by using our simple Excel. We can do the calculations, but nevertheless, it's doing Johansson manually. It will become very tedious process, and it is better to resort to a software. And not only this, if a person doesn't feel comfortable with using eViews, he can move to this programmable free softwares like R, wherein you can do all these things. Nevertheless, we will be working with eViews, and those people who are interested in doing in doing again on their own, what I am doing is you simply go to internet, search for eViews student version, install it, and then fill this proforma, and they will give you the code, and simply you can run your software. See, we have data. We have taken two data sets, X and Y. These two data sets have been inserted into your software. They have been done by going to File and then insert a new work file, and then you simply import this Excel sheet over there. Sometimes it may happen that your Excel sheet is not being imported. Just in that case, just change it to an older version of Excel, 97 2003, and that comes along with the Excel package, and that can happen. Sometimes there may be a glitch, but that can be overcome by just changing the version of your Excel, and then everything would be working fine. So we have taken a bivariate case. There are two variables, X and Y, and we are going to check whether there is a presence of cointegration or not. A word of caution: in order to use Johansson cointegration, we need to take care that both the series are I1. Meaning thereby, it should not be a case wherein one of the series or both the series are I0. I0 means if they are stationary at level. If they are I0, you can simply go into the VAR framework and do the things. VAR framework means vector autoregressive. We will cover this topic also in our coming classes. And also, it should not be the case that one of the variable is I0, meaning thereby one of the variable is stationary at level and the other variable is stationary at first difference. If this is the case, we cannot work with, we cannot perform Johansson cointegration with it. Also, it should not be a case where one of the variables is I1 and the other variable is I2, meaning thereby that that variable, one of the variables was not stationary at level, not stationary even after doing the first differentiation. It becomes stationary only after doing second differentiation. So in this case also, we will not be able to do Johansson cointegration. So I repeat, if variables are I0, one of them is I0 and the other is I0, we do not do Johansson cointegration. If one of the variables is I0, other variable is I1, we do not do Johansson cointegration. If one of the variables is I1 and the other is I2, we do not do, I2, then also we do not do Johansson cointegration. We can do this method of cointegration only and only if the one variable is I1 and the other variable is I1, then only we can do this method of Johansson cointegration. So, the first thing which we have to do is we need to do stationary t-test, and through this we need to ascertain that both our series are stationary at first order, or we have got those stationary after doing the first differentiation, that is they are I1. So this is one of the restrictions of Johansson cointegration, but a good thing is almost all of the series, or you can say most of the series, the economic series particularly, they are not stationary at level, but they become stationary upon first difference. There are very few series which become stationary after uh, second differentiation. Also, if such a case happens, we have a different process. We can go for Toda-Yamamoto test, or if it is a case of mixed differentiation, that is one of the series is like this. If suppose you have this case, in this case when one of them is I0 and the other is I1, you can do ARDL, auto-regressive distributed lag methods. If this is the case, then you can go for Toda-Yamamoto. So there are alternatives available, but if you somehow encounter such a series, then you better try to first increase the sample size. Let's say you take the maximum sample size and still you take the maximum number of years under observation, and still if you find that your data is either I0 or a mixture of I0 and I1 or a mixture of I1 and I2, then in that case you have to go for the alternate methods like ARDL on Toda-Yamamoto, or else you can simply go, or else if you have I1 and I1, very fine, you can go for Johansson cointegration. And if both of them are I0, you can simply go to your var, and var is nothing but you can say it's an extension of your simultaneous equation model. And in var, the good thing is you need not state, or you need not direct that this is independent and the other variable is dependent. In the var, that is the improvement of var over simultaneous equation. It considers both both the variables, once as independent and once as dependent, and they simply work on it. Today's lecture, we are concerned with Johansson cointegration. We are dealing the case where both the series are I1, and this is one of the most common phenomenon of economic time series data. Now, before going for testing for cointegration, the first thing was you have to do ADF test, and we have in our previous lectures we have done in detail how to perform ADF test. After ADF test, we go for ascertaining the lag structure. So for finding the lag structure, what you do, you go to the var framework. You have to go to the var framework. You go to var, and in var you will find these three options. Among these, you will be selecting the first one, that is standard var, which is being highlighted over here. You will select this standard var. Herein, you will write all the variables which are there, irrespective of which one you think is the independent or which one you think is the dependent. You simply write all the variables x, y. If it is a multivariate thing, you have z also, then you write x, y, z, and whatever are your variables, you insert it over here. And then in the lag intervals, you can increase the lag up to 4 5. That doesn't make a lot of a difference. But if your sample only, this is crucial only if your sample size is small. In small or large as such, see, this sample size being, what is the adequate sample size is again a question of deliberation, and it is subjective. But one thing is sure, that if on a small sample, and simply I am defining a small sample that is less than 30 years, if you are getting perfect results, it's by luck. Normally, you should have a large sample to have this understanding of a long run properties. And again, means that is also, it also depends upon context. Like maybe you say in case of GDP and all, you don't have maximum, you can have quarterly data, or normally you will find yearly data. Exports, you will find yearly data. So even getting 40, 50 years of export data is, or GDP data is a good figure. If you compare this with financial time series, or you compare this with inflation data, you can get inflation data daily, you can get financial like stock market prices not only daily but even hourly data, you can get it. For exchange rate, you can get daily data. So in that case, it's a different thing. But for GDP and other macroeconomic variables, you get yearly data, and for few of the years you can get a quarterly data. So if you are the basic crux of it is, if you are using time series data which are available on yearly basis, then okay, at least take care that we are having 30 or around these observations. We do not perform these long run co-integrating relationship test on data for 10 years or 12 years. They will not, they are not, in that case your results will be doubted. And in case of in case of financial series data or inflation data or these crude oil data, or even because these things fluctuate daily, foreign exchange data, gold price data, and commodity prices, these fluctuate daily, so you can get daily data. So for this, if you are having a case, then taking 30 observations becomes very small. If you are taking only 30 p day, that is a data for a month or a 45 days or 50 days, then it becomes understanding, making having implications based on this a small number of data is very it's not a good approach. So now in our case, we are having observations, 55 observations. It's decent. We may get good results provided all the conditions are satisfied. So the first step, ADF testing has been done. Then the second step which we are discussing is, we have to find the lag length that is to be decided. Lag length decision, it can be arbitrary, but better when we have an option, we should use it. We, in the realm of var, you will be doing it. So first we select var, we select all the variables irrespective of whether they are independent or dependent as endogenous. You can have lag lengths in 4, it's fine, and then you click on OK. You will get a result like this. This is basically a var framework. We are not going to discuss it at the moment, but uh, here the system on its own decides which is the optimum lag, how many lags of x and how many lags of y need to be taken in order to have a good explanatory power in the model. So it is, and also var, it is not considering whether x is independent or y is independent. At one time it is doing x1 x, taking x as the dependent variable and taking all other x minus 1, x minus 2, means a lag of x, and also y they will keep on calculating and calculate the best option. And similarly, next time it will take y as the dependent variable, and then it will go on computing, and it will accommodate the best lags based on its own structure. But this dialog box is not important for Johan in the reporting of Johansson cointegration. But from here, you will click on proc. Upon clicking on proc, you will get this lag structure. You will click on proc, you will get this lag structure, and in lag structure, you have lag length criteria. eViews is a very user friendly. Even if you are not a very expert, it's not like in programming softwares, you need to know the exact program. And even if it's a small letter or a capital letter, you need to know each and everything. Even in eViews, like here is the option of command. Here also you can write the command if you know the command. But for beginners, these drop down menus are very good. They can simply explore, okay, let us see where I find, I will just keep on clicking. Maybe I am by hit and trial methods also, you many a times come to the right conclusion. So this is a good option. These drop down menus are very easy for us to handle over here in eViews. So we go to proc, we go to lag structure, we go to lag length criteria. Once you have selected lag length criteria and you click on OK, then it will ask you to how many lags you can incorporate. See, if your data is small, let's say, and you say your data is of say 30 years and you give 10 lags, the software will tell that you are taking too many lags. It will not work. You need to reduce it. Normally 4 or 5 lags is sufficient, and if you are having 30 observations in 4 or 5 lags, the software will tell you which is the optimum lag that should be taken. So let it be 4, and then you click on OK. Upon clicking OK, this dialog box will open up. In this dialog box, you have this LR test, you have this FPE, then you have this AIC, Akaike, then Schwarz, then Hanan Quinen criteria based on an FPE also there. So it is giving you so many options and it is testing the lag through these 5-6 options as such. And the software gives you that which one is the optimum lag by giving an asterisk sign, a sign like this asterisk. Like here, this is given, this is given, this is given, this is given, and this is given. All of these luckily are saying that you should take only lag 1. You should not take lag 2 or lag 3 or lag 4. You should take lag 1. Now this is, I use the word lucky because you have got all the criterias are saying, whether it is AIC or SC or HQ, all of them are saying that you should go for lag 1. Sometimes it may happen that 2 of them are saying lag 1 and 3 of them are saying lag 4. Maybe this can be a case. In all those cases, we go by the principle of parsimony. We take the simplest of the lag. We take, suppose even if 4 of them, there are 1, 2, 3, 4, 5, even of them 4 of them are saying take lag 3, and 1 of them is saying take lag 1. Go by take lag 1. You make that particular criteria. Suppose it is Hanan Quinen criteria is saying that take lag 1. You just have faith in Hanan Quinen criteria and take lag 1. So we go by the element of parsimony. So now the software has indicated that while doing your cointegration, how many variables of the lag model, how many lag models you should take, and that is 1 over here. So this is what we needed from the VAR framework, and that chapter is closed. We need not take any help other from the VAR framework. Now we go to the option of quick. Then you go to group statistics. And then in group statistics, you will find Johansson cointegration test. You go to quick, you go to group statistics, and you go to Johansson cointegration test. Also, one care should be taken that do not close the earlier window. Like this window we have got earlier when we were selecting the lag length. So do not close this and then again start. No need, you just start it from here. Because sometimes if you close the previous window, like we will see in our later case, after Johansson cointegration, we have to go for error correction term. And when you go for error correction term, if you have closed the window of Johansson cointegration, the results will not come. So do not close an earlier existing window, let it be there and you work. So once you have estimated var, that don't just click on X, don't click on this. You simply go to quick, you go to group statistics and you go to Johansson cointegration. When Johansson cointegration you have clicked, this dialog box will open up. It is asking you to give the name of the series. Now here we have to be very careful. We put the exact names X and Y over here. You have to put the exact names and try, although this is not very important, but try and put the variable which you assume that is the dependent variable. Although in cointegration as such we do not say that X is independent and Y is dependent, but nevertheless something goes in back of our mind that okay, Y is we are assuming Y to be the dependent variable and other variables are the explanatory or the correlates or the independent variables. So you just write the dependent variable first, what you think to be dependent, and the other variables you write later. But this does not mean that you are assuming that Y is the dependent. Only for the process of calculation, you need one of them to be identified as a dependent variable. And you need to write it first. So once you have, now, when you are preparing your data in Excel, don't keep very long limbs. Don't put gross domestic product because you have to then type the entire thing gross domestic product. And if one letter is missing or one gap is missing, the software will not recognize it. And the moment you keep on working, the moment you write Y, it will automatically, if suppose here 10 items are there and you have, suppose you have written GDP and export, the moment you write G here, it will automatically show here GDP. So by using those things also you can help, or if you have kept your names of your data sets, you know what is X, you know what is Y, you just keep them very simple, X1, X2, X3 or X, Y, Z, A, B, C, or very short forms. Instead of gross domestic product, just GDP. Instead of export, just EX. So these things will make your work easier. Then you select OK. Once you have done that, you move on. Now this dialog box will again open up. Now if you read it, now what is this saying? The first option, assume no deterministic trend in the data. Then in that case you have no intercept or trend. The second case is there is intercept but no trend. Then normally there will be a deterministic trend in the data. We don't get data like this. We don't get always data like this, in particularly in economics, that everything is going just like this. Maybe you can say inflation is something like this, but GDP, there will be a trend. Even if there is no economic activity going on, one of the components of GDP is consumption. Each and every country's population is increasing and mortality rate is decreasing. So there will be an increase in consumption. So there will be a movement like this. So normally these two options are not selected. Now what is this option? Intercept, no trend. This can be the case. There is an intercept but no trend. And intercept and trend, both of them are included, intercept and trend. Also intercept and trend over here in C. So now, and the option 6, it summarizes all of this. But as you gain expertise, you will find that you will be getting results, or if you go for research papers, you will be getting results based on 3 or 4 itself. And you have the option. Suppose you have gone for 3 and then you do the calculation. Suppose something goes wrong and you don't get the results, then what you can go, you can again come back and now you select this one, number 4, and then again you do the remainder of the steps. So that can be very well done. So a word again, that case 1, if the series has 0 mean, it is not plausible, it's not normally it's there. Case 2, when it seems that the series does not have a trend, that also almost or most of the series they do have a trend. And series have trend and all trends are stochastic. Normally this is the case. You have trend and those trends are stochastic. Case 4, if the series have trend but some of it may be stationary. And number 5 is if is good fit in sample but not good fit in forecast. But what the basic thing is, we will restrict ourselves to case 3 and case 4. We will, if the results are to come, we will get these from this. I am talking with my experience that either in case 3 or in case 4 you will be getting your results. Also, I need to also emphasize over here that before starting for any type of analysis with time series data, the first thing which you should do is you plot the data. Plotting the data will give you whether the trend is like this or the trend is like this, or there is something the trend is like this. Once you plot the data, you will get an idea. Based on this, you can choose any one of these criterias. Now, once you have done, now you get, this is the result of regression. This is the result of cointegration. Now, herein, there are two type of tests: trace statistics, max statistics. Okay, over here, trace statistics and max statistics. There are two type of values are reported. And even if you are not a very expert in these softwares, the software will give you a result. Trace statistics indicate one cointegrating relationship. Again, maximum eigenvalue test indicates one cointegrating relationship. So the software itself will give you a clear-cut answer that whether there is a cointegrating relationship or not. Here you can get 0 also. It is 1 written over here. If somehow suppose it is saying that this is 0, it means there is no cointegrating relationship between these two. Then you can go for the other options. You select option 4. You redo the calculation, or select option 5 also and redo these steps, or even you go for step 1 and step 2 and redo it. And if you find in any one of them this changes from 0 to 1, you take that result. That can be done. But the thing is, the point of emphasis over here is that the trace statistics and max statistics, they are the one which indicate whether there is an cointegrating relationship or not. And all this, the result itself is, the software itself is giving you the result as such. From this, like in our case, we have seen, in our case, we can confidently report that there is a cointegrating relationship between the two variables under study, that is x and y. We will now, not only this, but our work doesn't end over here. Just finding cointegrating relationship by using trace statistics and max statistics doesn't serve your purpose in totality. You have to next go for the error correction term. We will continue with this error correction term, and we will see the significance of it and how to calculate this in our next lecture. For the time being, thank you.